All right, I'm gonna get started. So you don't have to add this if you don't want to, but I'm just gonna give you some examples right below the problem. So for example, on this one, if I had something like 5 to the 0, that's equal to 1. If I had something like y to the 0, that's equal to 1. If I had something like 7,000 x to the 1 million, all to the 0th power, what is that?
1.
1. Okay, so that's equal to 1. So that's what that means. The second one here is about having a negative exponent, which to this point we've ignored. But if I write something like x to the negative 11th, that's actually equal to 1 over x to the positive 11th. So if I have a negative exponent, that's the same thing as writing it as 1 over x to the positive 11th. And similarly, this is going the other direction. This is saying if you have 1 over y to the minus 9th, that's actually just equal to y to the positive 9th. I like to think of this as upstairs and downstairs, meaning if you have a negative exponent upstairs, you can think of this as being over 1. So my negative exponent is upstairs. If I just put that downstairs, it creates it as a positive. Similarly, down here, I have a downstairs that's negative. I can put it upstairs. You can think of this as over 1, and the exponent's now positive. It's basically changing where it is, and it changes if it's positive or negative. All right, this next one is something like this. If I have x to the 7th over x squared, that's going to be equal to x to the 7 minus 2 is x to the 5th. So that's kind of the big rule we're learning today. And I'll explain later why that's true. All right. And the last one is exactly what you think, where you're putting that a in for both of them. So an example of that would be if I had 5 over x squared squared, I have to apply that squared to both terms. So 5 squared is going to give me 25. And then x squared squared, we know that this is 2 times 2. It's a power to a power rule. That's going to be x to the 4th. So this is really similar to that distributive property that we were learning before. Questions on this before we start to do actual problems? Do you think history is more interesting than math, or math is more interesting than history? I just sometimes wonder, I'm like, is this interesting to students or nah? All right, so here's an example of why this is true. So go ahead and write x to the 5th divided by x cubed. And we can write this out the long way. So I know x to the 5th is x times x times x times x times x 5 times. And I know that x cubed is an x times an x times an x. So I can always cancel out common terms. So for example, here I cancel out those x's, these x's, and these x's. And I'm left with x times x, which we know is x squared. And so I've just proven to you why this property works. This idea of subtracting 3 is why 5 minus 3 would give you the 2, because we're basically getting rid of the 3 on the bottom. Okay? All right, let's go ahead and do some practice problems. And I want to kind of ramp it up, meaning make it easier and then we'll make it harder. Nope. All right. Let's go ahead and label this example 1. And we'll call this So, the rule, and I didn't say this before, you always want to subtract the smaller number. What I mean by that is, we're going to subtract 4 right here, and I'm going to subtract the 4 here. The reason I chose the 4 is because it's smaller, and I don't want to end up with negative exponents. So I've got x to the 5 minus 4. What is 5 minus 4? 1, so it's just x. X to the first, if you want to put it like that. And then what is 4 minus 4? 0. And what's x to the 0th power? 1. And so this 1 disappears, and you can go ahead and just cross that off like that. So now that's gone. So now let's go ahead and let's deal with the y. Am I going to subtract the 7 or subtract the 11? Yeah, so we're going to go minus 7 minus 7. And so what happens with this 7 minus 7 and this y to the 0th? What can we do to it?
Take it away.
Take what?
Take it away.
Yeah, cross it out. Bye-bye. And then we are left with y to the 11 minus 7. That's just y cubed. Okay, and I can rewrite that without the parentheses. That would just be x over y cubed. Feeling it? You seem a little tired today. All right, let's go ahead and do example 2. We're going to add some numbers in here. Are you okay? Let's go something like 8x to the minus 11. Get that down. All right, first thing we're going to do is deal with the 8 divided by 2. What is 8 divided by 2? 4. And 4 is 4 over 1. So I'm just going to keep that 4 in the numerator. 8 divided by 2 is 4. Now, which one? Should we subtract a 13 from both sides? Should we subtract a negative 11? Which one's small? Let's answer this question. Which one's smaller, 13 or minus 11? Minus 11. So everyone watch this. This is probably the hardest thing we've done today. I'm going to be subtracting a negative 11. So I am subtracting, I'll do it in green, subtracting a negative 11. Subtracting a negative 11. And what happens when I'm subtracting a negative? That becomes a positive. So you're going to actually be doing a plus 11. I still want you to think of it as subtracting a negative, because this rule is about subtracting. But now I have a negative 11 plus 11 becomes x to the 0. This disappears. And now I get x to the 24th in the denominator. So you still want to subtract your smaller number. It's just when you're subtracting a negative, it becomes addition. All right, now here, do I want a minus 5 or minus 2? Yep, so I'm gonna minus the 2 here, minus 2 here. So here I'm gonna get a y cubed, because 5 minus 2 is 3, and then this one is gonna cancel. And I am done. All right, one more and then I'm gonna let you try it on your own. In fact, I'm thinking let's go ahead as a group and do, let's do number 35. Everyone go to page 3, we're gonna do 35. Okay, the thing about this problem is we kind of have to simplify first before we even apply our rules. Can someone check that I wrote this down right? Because it's quite a bit. I think it looks good. All right. First step is let's go ahead and do 3 times 3, which is a 9. And then let's go ahead and combine our a's. I've got an a to the first times an a cubed. This is the first day that we learned this week. And we add the 1 plus the 3. That's going to give me an a to the 4th. And then I just have a b cubed. So I'm just rewriting the b cubed. So all I've done is combine the a to the first and the a cubed to be a to the 4th, and then 3 times 3 is 9. Now in the denominator, I have a to the first times an a cubed. That's going to give me a to the 4th, and then a b. Now what happens when I have two things that are exactly matching? I can do what? Yeah, cancel them out, cross them out. So I'm just going to go cancel, cancel. And now I'm going to write a 1 for this b. Am I going to be subtracting the 3 or subtracting the 1? Okay. So subtracting the 1, subtracting the 1. So this is going to give me a 9b squared over 4, because this b to the 0 is going to cancel. And we are done. I don't want you to panic on worksheet number 3. I feel like this is the biggest challenge I've given you so far, but practice helps us find our mistakes. All right, go ahead and start worksheet number 3. Feel free to talk to your peers.